In this segment, we'll create a simple animal subclass and look at a couple of important object-oriented design patterns that the subclass illustrates. Animal provides the most fundamental animal behavior: an ID, location, velocity, toString method, and basic movement. If this behavior is sufficient, we can quickly create a class for a specific animal by deriving from animal. Our subclass will need only a constructor and an override of the getLabel method to return the right letter. All the other methods of animal will work fine, including animal's toString, which, as we discussed, will call the subclass's overridden getLabel because getLabel is polymorphic. So let's try a sloth here. The simplest possible implementation looks as shown here in the diagram and the notes. And first off, we've got to have a constructor. Now, as we said in the discussion, you may recall, of margin vector, a subclass has to have its own constructor, unless the superclass has a parameterless default constructor. But that's not the case here, so like the margin vector constructor, sloth's constructor just passes its parameters along to the superclass animal constructor, which will initialize the animal portion of sloth. And then we also need to override getLabel, which just returns question mark at the animal level, right? The animal.getLabel returns question mark. But also, as discussed earlier, we do not need to redefine toString. The animal version calls getLabel, and we've redefined getLabel in this case to return an S, standing, of course, for sloth. Now, toString and getLabel illustrate an important design pattern. We have a superclass method toString that calls another superclass method getLabel as part of its work, like here in the diagram. But that method, the getLabel method, is intended to be overridden, and we customize the behavior of toString without overriding toString by overriding the getLabel method on which it depends. This particular pattern happens all the time in object-oriented design, though usually with more complex methods. A superclass method that does some intricate task, many lines of code long, will call other smaller methods in the same superclass to do small, customizable tasks, like returning a label letter. Then subclasses override the small methods to adjust the behavior of the large method without having to repeat the large method's code. This pattern is the first we have encountered of the classic Gamma et al., or GOF in our abbreviation, design patterns. It's called template method and is one of the most commonly used patterns. It will show up at least once more in this version of CodeWorlds. Watch for it. Now, let's make our sloth a bit more interesting. Being a sloth, he really should slow down. So we'll reduce his velocity by 10% on every step. We can do this by scaling VLC by 90%, multiplying by 90% on each step. VLC.scale by 9.9. This will require overriding step to include this new action. But do we have to rewrite the whole method just to add that one extra action at the end? No. In effect, what we want to do is everything animal's step already does, plus a final action of scaling the vector. And we can do this by calling animal's step from sloth's step like this. The super.step method, or a statement, calls the superclass's version of step to do all the main work, after which we add the one extra touch of scaling the vector velocity by 0.9. In general, any overridden method may call its superclass version via this notation, the word super and then the method in question, at any point in the method body. And here's a small diagram of this idea with the dashed arrow line here indicating that sloth's step is calling up to animal's step. There's no particular name for it, but this is also a very common pattern. For this class, or course, we'll use the term upcall. An overridden method frequently needs to add just one small adjustment or extra computation to the logic already provided by the superclass version, and it does so by upcalling, by doing a super.methodName call, and adding a few extra lines of code. So now let's test our sloth class. And to do that, I'll add to sloth a main method that creates a new sloth object and runs it through a few steps. So bringing Eclipse up here, this is the main method in question. But that deserves a bit of discussion. You've seen main methods, of course, but sloth is not the main class of this application. CodeWorlds is, and we'll get to it soon. And CodeWorlds has its own main. Can two or more classes in a Java application have a main? Absolutely yes. And it's common to do so for testing purposes. When you run the app for real, you designate the main class, and it must have a main method, which starts the program. But any class may be executed for test run purposes. All that is required is that it have a main method meeting the right criteria. Now, every one of these keywords is essential. It has to be public and static, and it must return void, and it must be named main, and it must take an array of strings as a parameter. That array, by the way, holds command line arguments, as you may know. We'll have an example of that later. Now, miss any one of those requirements, and the Java interpreter or Eclipse or whatever is executing the class for you rejects your class for lacking a main. But get it right, and you can run any class as if it were a small app. Now, here's a question for you. Why does it make sense that main would have to be static? Couldn't we make it an instance method? Think about what's going on when the app starts and why an instance method wouldn't work. So returning from a pause there, because when an application begins, there are no objects yet allocated. We can't have done a new sloth when the program's just starting. Thus, no context object will exist, and only a static method could be called. Okay, question 2. Just a bit of a reality check here. Can't we just call step directly from main since it's a method of sloth? Again, after some thought there, I won't keep drilling this forever, but getting static and instance semantics clear is important. As a static method, main has no context object, but step, as an instance method, requires one. So we must first create a sloth object, sloth instance, in main, and call its instance methods. As you can see, we set up a sloth that is located near the upper left corner of the simulation area, the grid, with a velocity moving to the upper right. We then set a range for animal, and then we call several step calls on the sloth, printing sloth's status at each time. Okay, now another reality check. We use an animal reference throughout the main. So won't we end up calling animal step down here? And after what I hope is a short pause, polymorphism. The object is a sloth, and we'll get the sloth step method even if the reference is an animal. In question 4, again, a bit of review. Okay, but then will the sloth's step method respect the animal range that we just set here? Again, returning from a pause. Yeah, sure. First of all, sloth's step method calls animal's step, right, which will respect the range. And we could have used animal.range in sloth's step directly, since sloth inherits the range from animal. Now, let's run this thing. I'll bring up the Eclipse window here and the console window, and we'll do a run from Eclipse. And I'm picking Sloth Java as the main class and running it as an application there with the output. And by the way, the vector2 string, I'll show that up here briefly, has been updated now, modified, to return a formatted string, so we don't get those potential 20 decimal digit fractions. If you don't know about the string.format method, it's worth looking up. Check it out in the docs. It's basically printf for strings. Now, question 6 for you. Why does the velocity, right there, change direction after the fourth step? You can see it switched signs on the x component. What code in Sloth says to do that? Returning from a pause, but there's no code in Sloth that directly says to do that. It's the animal step being called by superstep here, and it's making a right turn when the boundary would have been overstepped. We were right up against the boundary right about here, and then had to change direction to keep from going over it. Now, let's close here with a brief debugging hint, since we have Sloth up and running. When you do an upcall, it's easy to forget the super. And, for instance, just call step. Now let's see what happens if we do that. I'm going to run Sloth again here. Yow. So we get a rather dramatic stack trace. And on the top, way up here, it says something about a stack overflow error. So question 6, what do you think happened here? What did that step statement without the super actually call? Returning from a pause, step is calling itself. So we get a sort of impromptu recursion, and a bad one at that, since there's no end to it. The runtime stack that stores the locals and parameters for successive recursive calls is quickly overwhelmed, and this is what you get. So watch out for this error and remember the symptom.